Hey folks, today's topic is solving systems of word problems. So the tough part here is getting the word problems written out. After that, solving it is pretty straightforward. So I want to read through the story and I want to look for the things that are changing. Those are going to be my variables, the things that I don't know. So over here, I'm going to always start off by trying to define what my variables are. X equals and Y equals. We need to state what they are before we get going. So the cost of a taco and a soda pop is $2.10. The cost for 2 tacos and 3 soda pops is $5.15. What's the difference between the cost of a taco and a pop? So what we don't know is how much a single taco costs and how much a single soda pop costs. So that's what I'm going to define as my variables. X equals cost of a taco. Y equals cost of a soda. Then I want to try to turn these into stories. I want to turn these stories into equations. So there's 3 different styles of equations, and this first one is an example of what we call a total. Because in the story it says the cost of a taco and a pop is a total of $2.10. So I'm going to turn that into an equation. So how much does a taco cost? We don't know, but we have defined what it is. So we could say the cost of a taco is X, and, well, that means add in the world of math, and a soda pop, well, we don't know how much a soda pop costs exactly, but we have defined a variable to represent that cost. So the cost of a taco plus the cost of a soda would end up being $2.10. Now we're going to do the same thing for our second equation. So this is an example of a total twice. Both of the equations are total equations. What I'm going to do after this, and in the homework, you might have a total mixed in with some of these other ones, but this is a total situation that occurs twice. So in our second part of the story, the cost of 2 tacos and 3 soda pops. So 2 tacos, 1 taco is X, so 2 tacos would be 2X. 3 soda pops, 1 soda pop is Y, so 3 soda pops would be Y. Adds up to a total of $5.15. Okay, so now how to solve this. You could go through and you could try to cancel some things out. I'm going to show you a shortcut using matrices. So we just talked about matrices. I'm going to flip over and we'll come back to the front. So when you're doing story problems, or anytime that I say you can do it without solving by hand, you can use your calculator, A inverse B or polysymol, to solve a system of equations. So what I'm going to do is I'm going to show you how to do the A inverse B steps first, and then I'll show you how to do polysymol. So you want to think about this system of equations as 3 matrices. I'm going to make first what's called the coefficient matrix. -1, 2, 1, -3. This is what we call the coefficient matrix because it's all the coefficients multiplied by the variable matrix, and our variables are X and Y. This is our variable matrix, and that's going to come together to make the constant matrix, -1 and 6. That's what we call the constant. Now, if I took these matrices and I started to multiply them, remember how matrix multiplication works, I would have to do row 1 times column 1, and that would give me this term. And that's exactly what our first equation looks like. -1 times X is -X, plus 2 times Y is 2Y, and that would equal -1. Row 2, column 1 would give me row 2, column 1. So 1 times X is X. -3 times Y, so I'd go negative. Remember how we multiply matrices. 1 times x would be 1x. Negative 3 times y would be negative 3y, and that would come together to make 6. So this system of, or this equation of matrices is the same as this system represented up above. Now, we didn't talk about this when we did our operations of matrices. Well, let me turn this into, let's name these matrices. I'm going to call this the A matrix. I'm going to call this the X matrix. And I'm going to call this the B matrix. Now, we didn't talk about division, because if I said try to get X by itself, we'd have to divide both sides by A. Well, there is no matrix division. So what we do instead is we do this thing called multiply by the inverse. So A inverse times A cancels each other out. I mean, that's similar to, like, let's take the number 3/2 and multiply it by the number 2/3. They would all cancel each other out, and you're left with just 1. That's exactly what happens here when we multiply by the inverse. Now, matrix multiplication is kind of weird. What side you multiply by matters. So if I multiplied on the left side of A, I need to multiply on the left side of B to keep things consistent. And we get this equation now. Remember, these two cancel each other out, and I get X equals A inverse B. This is a big deal. This is one of the things you're going to want to memorize. Put a little star next to it. Because what I can do then is I can make these systems of equations into matrices, and then I can plug into my calculator A inverse B, and it will spit back my solutions. So let's take a look at I'm going to use my alpha F3 to go into matrix. If you don't go here, remember the other option is matrix and then go over to edit. So I'm going to use mine. Let's go ahead. Matrix edit. Matrix A is going to be a what? 2 by 2. Negative 1, 2, 1, negative 3. Now I'm going to make matrix B. So I got to go back into matrix, go to edit, go down to B. What is this? This has 2 rows and 1 column. Let's say you mix it up and you do 1 by 2. You can see that this matrix does not go the same way as this matrix. So just push back upwards and then change it to what it's supposed to be. And now this matrix looks like the one on the paper. The one on the calc looks like the one on the paper. All right, so I've made matrix A. I've made matrix B. Now I use this magic solving formula. So now I need to select matrix A. Okay, inverse. Your calculator is designed very well. They will put things in places that makes a lot of sense. We mostly use the matrix button with the inverse button. So right with matrix, just like sine and sine inverse, cosine and cosine inverse, matrix and the inverse button are right by each other. So I selected the inverse times second matrix, and now I want to select matrix B, and we get negative 9, 5. What that means then, so let me go back and remember what that is. That's going to take, what color was I using? So if I went back to this equation over here, this was X equals A inverse times B, and we got negative 9. That shouldn't be there. Negative 9, negative 5. Well, negative 9, negative 5, that's the solution. Remember, the X matrix is what we're trying to find. The X matrix was the matrix X, Y. So this is telling us our solution to the system is X equals negative 9 and Y equals negative 5. Or if we wanted to write it as a point, negative 9, negative 5, and I usually prefer it as a point. All right, let's try another one together. So I can't use this trick, A inverse B, unless my equations are in standard form, because I have to have the X and the Y in order, X and then Y, and then the constants. So our equation here is not in that format. But we can multiply an equation by whatever we want. So I'm going to take this equation, and I'm going to multiply it All right, what could I do to clear out these fractions? Times by, what number could I times by that would clear out a divide by 2 and a divide by 3 in one move? Well, hopefully you said a times by 6. Now remember, you have to times everything by 6. So 6 times negative 2 is negative 12. 6 times 1/2 is 3 with the y. 6 times negative 4/3. So the 6 divided by 3 is 2. And then the 2 gets times by a negative 4. So that would be negative 8 with the x. Now this still isn't in standard form. So I want to manipulate things. I'm going to bump the x, the negative 8x across, and I'm going to bump the negative 12 to the other side. So I would have 8x plus 3y equals positive 12. What do you think? Now I'm looking at the second equation. The second equation is also not in standard form, but it's much easier to manipulate it. I'm just going to flip them. I'm going to flip them, not even going to worry about the changing the signs at all. I'm just going to write this side on the left and this side on the right. So I've got x plus 3y equals negative 9. Now, you might remember from Algebra 2 or Algebra 1 that we could subtract these and cancel out. That's something we're going to talk about next time. Today's goal is just to talk about how to do these using our calc. So now I'm going to make two matrices. This is going to be my A matrix. This is going to be my B matrix. And I'm going to use this trick, A inverse B. Clear it out. Second matrix. Edit. Matrix A is a 2 by 2. And the number coefficients are 8, 3, 1, 3. Second matrix edit is a 2 by 1. That's a 12 and a negative 9. Quit out. Second matrix A, hit the inverse button, which is above matrix, times second matrix B. So we get a solution of x equals 3, y equals negative 4. X equals 3, y equals negative 4. And if you want to just cut right to the coordinate pair, that's fine with me. If you don't want to show all that work, you probably have to show this work to be able to get your equation set up, but the rest you can do on your calc. All right, you try to pause here and try to do example 3 on your own. All right, let's see how you did. So I need to find something to multiply this by to kill off the fraction. So what would kill a divide by 8 and a divide by 2? You could use 16. You know, a guaranteed way is to multiply these two things together and multiply by that. That would definitely kill it off. I'm going to use 8 because 8 is the least common multiple. So I'm going to times this by 8. So negative 3/8 times by 8. The 8's going to cancel. I'm left with negative 3x. 8 times 6 is 48. 8 times 3/2, I'm going to divide by the 2 first. That makes a 4, and then 4 times 3 is 12 with the y. This is not in standard form, so I'm going to do a double move here. I'm going to bump this 12 over, and I'm going to bump that 48 over. So I have negative 3x, subtract 12y, equals negative 48. I'm now in standard form. This equation is also not in standard form, but it's easy to manipulate. I'm going to bump the x out front, negative 7x. I'm going to push the y to the back, and then I'm going to bump the 12 over. Now I need to create my matrices. This will be matrix A. This will be matrix B. And then I'll use the magic formula, A inverse B. Negative 3, negative 12, negative 7 and 4. Second matrix, edit. Go down to matrix B. This is a 2 by 1. Negative 48, negative 12. Quit. Second matrix, enter. Inverse. Times. Second matrix, B. 3.5 and 3.125. I should have showed you on this one. I'll show you in a second here. I'm just going to go right to the answer. So the answer for this one would be 3.5, comma 3.125. So let's say you're somebody who remembers how to do fancy calc stuff. with their matrices. Another way to do this is to go right and build your matrices and do the inverse right on your calc. So alpha F3, the first is a 2 by 2, a 2 by 2, okay. -3, -12, -7, and 4. And now I want to hit the inverse there because I want to inverse, that's A, inverse, times, and now I'm going to make matrix B, alpha F3. That's a 2 by 1. And then a -48 and a -12. Either way is going to give you the same solution. All right, if you think that that's faster, go that route. If you think it's faster to do A inverse B, I don't care. All right, so there's another method that I can show you too. I want to give you as many calculator tricks as you can. Not so much for this year, but for next year when you have to do this again in one of your first entry-level college calc classes. And there's something called polysymalt on your calculator. Polysymalt, let me clear this out, is underneath apps. Now, if you don't have this, I can install it if you have a TI. So I go to polysymalt. That polysymalt stands for polynomial root finder, that's the poly, and then simultaneous equation solver, that's the simul. We want to do the simultaneous equation solver. So I'm going to now select this. I'm going to go down to simultaneous equation solver. And then here I want to ask my calculator, or tell my calculator, I should say, how many equations do I have and how many unknowns I have. So I could go back here. I have 2 equations, enter, and I have 2 variables, 2 unknowns, enter. The rest of this stuff you can it doesn't really matter what you have there. Now I'm going to hit next. This is going to give me the coefficient matrix and the constant matrix in one screen. -3, -12, -48, -7, 4, and -12. Now I can just hit solve here. See how that says solve? That corresponds. Each one of these, I guess I didn't explain that. Each one of these little on the screen buttons corresponds to the buttons underneath them. So if I wanted to go back to the main screen, I would hit main and it'd take me back here. Simultaneous equation solver. I wanted to hit next, so that's this button here. Now I've put in all my coefficients and my constants, so now I can hit solve. Now look, this one gave me it as a fraction because if I go back to mode, you see how I have it set up as a fraction? If I want it to be decimal answers, it'll spit back your answer as a decimal. Either way, sometimes I like fractions better, so maybe I would leave that as a fraction. All right, so let's try polysymalt to solve these. So I'm going to go back to mode because how many equations do I have? I have 3 equations. How many unknowns do I have? I have 3 unknowns. Decimals or fractions, I already know the answer, doesn't matter here, so I'm going to just now go to next. All right, so it gave me 3 rows with 3 columns and then a column for constants. So 4, 1, -5, and then put in your constant, 0. 5, 4, -4, and 7. -2, -3, -3, and 4. And then solve. Bum, 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 bum. Here's your solution. So x would be -5. Y would have to be 5. And z would have to be -3. This is called a 3-dimensional coordinate triple. We will talk about that in Unit 9. We're going to do some 3D graphing in Unit 9. So let's have you solve this one. Either way, you can pick A inverse B or polysymalt. I don't care which. All right, let's say I want to do polysymalt. I want to hit system because that takes me back here. And then I'm going to put in all the numbers, 2, 6. Oh, interesting. There's no z value, so I've got to still save that place with a negative or with a 0. -6, and then the second row is 2, -6, 2, and then 16. And then -x would be -1, then a +6, a -2, and a -19. I've got all my coefficients in. Now I can just hit solve. Solve, and we get -3, -2, and 5. Now let's say I did that with A inverse B. So I just keep hitting quit to get out. Second quit, second quit, second quit. So now I'm going to go in. I'm going to go second matrix. This time I'm going to make a 3 by 3. Negative 2, 6, 0, 2, negative 6, 2, negative 1, 6, negative 2. I just put in all the coefficients. Second matrix. My bad, I'm lost. Here, hold on. Second matrix, edit, because I'm creating. This one is a 3 by 1 because I need 3 rows. Negative 6, 16, and negative 19. Quit out of there. Second matrix, A, inverse. Second matrix, B, negative 3, negative 2, and 5. There we go again. And then the last way you could do this is right on your screen, alpha F3. If you have fancy calc, this is a 3 by 3. Negative 2, 6, 0. 2, negative 6, 2. Negative 1, 6, negative 2. Inverse times, and then I'm going to make another matrix. This one I want to be a 3 by 1, negative 6, 16, negative 19. Same answers, same results. All right, so now we've talked about how to solve systems of equations on our calculator. So anytime you do a word problem, I would recommend using systems to solve this. So we have a system that's already in standard form. We just talked on the back all the different ways that you can solve it. So how you want to solve it from here is totally up to you. I'm going to use, this time I'm going to just use this screen to do it. So I'm going to set up my calculator, alpha F3. That's a 2 by 2. My coefficients are 1, 1, 2, and 3. That's inversed multiplied by my constant matrix. So that's alpha F3 again. This is a 2 by 1, 2.10, and 5.15. Enter. And so I get a solution of x equals 1.15 and y equals 0.95. All right, well, that makes sense. I mean, that's pretty cheap taco and pretty cheap soda, but that means that the cost of a taco is $1.15. The cost of a soda is 95 cents. Now, what's the question? Don't box that in. Make sure that you read the question. What is the difference between the cost of a taco and a pop? So $1.15 and 95 cents, if you subtract those, that's a difference of 20 cents. So a taco costs 20 cents. I'm going to write mine as $1 more than a soda. All right, so this is an example of a total type of a story problem. The total is $2.10. The total is $5.15. Now let's look at another style. So Palanzio's charges $6.80 plus 90 cents per topping for a pizza, while Guido's charges $7.30 plus 65 cents a topping. How many toppings are needed for Palanzio's and Guido's to cost the same? So let's start off by identifying what we don't know. X equals and Y equals. Okay, what we don't know, they charge $6.80. So as soon as you walk in the door, they charge $6.80. And then they charge you 90 cents per topping. So what one thing we don't know is how many toppings we got. The number of toppings. What else would matter? When you go into the pizza place, you say, here are my toppings. What do they say back to you? How much it's going to be. So the two things we don't know is how many toppings and then total cost. I call these examples, I call these beginning and change. I think I'm going to change my plan here a little bit. I call this a begin and change. Because right off the bat, as soon as you walk into Palazzo's and you start ordering a pizza, how much are they going to charge you? They're going to charge you right off the bat $6.80, no matter what. Then they're going to charge you more based on how many toppings you get. Well, how many toppings did we get? We don't know the exact number, but we did define it as a variable. So we know that we got X toppings, and each topping costs 90 cents. So the total cost of toppings would be 90 cents times X. So if you take the base price, the initial price, the beginning price, and you add the changes based on how many toppings, what would that add up to? That would add up to the total cost, and we define Y to be total cost. When we go to Guido's, we start off right as soon as you walk in the door, they charge $7.30, plus they only charge 65 cents per topping. When we add those together, those equal the total cost. So this is a beginning and a change problem, and this one also occurs twice. All right, so now once you have the story written in its equation format, you can solve it however you want. I'm going to solve this one. Well, either way, I got to get it in a standard form. So I got to get X and Y on the same side and the constant on the other side. So I'm going to bump over the Y and I'm going to bump over the 680. So that would be 90 cents X, subtract Y equals $6.80. And then I'm going to bump over the Y. I'm going to bump over the 730. Ooh, it would be negative. Sorry, negative 680 because I got to subtract it. So I'm going to subtract the Y and I'm going to subtract the 730. So I would get 65 cents. Subtract the Y equals negative 730. This time I'll use polysymol. So that would be underneath apps, polysymol, enter. Simultaneous equation solver. This time I have two equations. I have two variables. I need to tell my calculator what the coefficients are. So 0.9, negative 1, negative 6.8, 0.65, negative 1, negative 7.3. I can solve, and then I get a solution of x equals 2 and y equals 8.6. Now let's stop and go back to our variables and decide what this really means. X is the number of toppings, Y is the total cost. So when we solve the equation for Guido's and the equation for Palazzo's, and we get this as the solution set, that means at two toppings, both pizza places charge $8.60. So the question was, how many toppings are needed for them to cost the same? So our answer then would be the pizzas cost the same at two toppings. The pizzas cost the same at two toppings. All right, now our last style is called related. So let's go through and try to define our variables first, and then we'll come up with how it works. So Norm sells sundaes for $2 and cones for $3. On a hot day, the shop sold 8 more sundaes than cones and made $156. How many sundaes and cones were sold altogether that day? Why is that italicized? I'm going to have to fix that. That's weird. Okay, so what do we have? Our unknowns. Do we know how much he charges for a sundae? Yes, $2. Do we know how much he charges for a cone? Yes, $3. So that's not the unknown. What we don't know is how many were sold. So X stands for number of sundaes. Notice I didn't write just sundaes. Sundays aren't a variable. Number of Sundays are a number. That's a variable. Y equals number of cones. All right, now let's try to turn this into an equation. Well, one of these is easy. The 156. 156, they sold a total of 156 cones. Sorry, 156. Let me try again. They made a total of $156. That's easy. That's a total. Totals are my favorite to write. I think they're the easiest to understand and the easiest to write. So if you made a total of $156, what made up that total? Well, they made money on Sundays. How many Sundays did they sell? Well, we don't know exactly, but we can call it X. If they charged $2 for every Sunday, they made 2 times X dollars on Sundays. Cones cost $3. They sold Y cones, so 3Y represents the money they made on cones. This is a total with a related. Now, what I mean by related is this sentence here. The shop sold 8 more Sundays than cones. So that gets a little bit tricky there. So what do I mean by 8 more? So let's go over here on the side. We know 8 more means add 8. That's pretty obvious. But what gets tricky is where do we put the plus 8? So what I learned as a kid, because I could never do this on my own, is I would write it out both ways. I would say X plus 8 is Y, or Y plus 8 equals X. And then I would use my variables to try to understand which one made sense with the story. The shop sold 8 more Sundays. That means the Sundays should be the bigger number because they sold more Sundays. So if I look at this equation, this would say X is Sundays. Sundays plus 8 more would add up to the number of cones. No, that doesn't work because Sundays is supposed to be the bigger number. If you take a bigger number and add 8, you would get an even bigger number. So this one is no good. I can cross this one out. Now let's make sure the second one makes sense. Take the number of cones, add 8 to that number, and you'll get the number of Sundays. That works because you take the cones, which should be the less amount, and you add 8 to get the bigger amount. So now I'm going to take that equation and I'm going to bring it back over here into my system. That's what we call a related. That's what we call related. Now this has a related and a total. This is the only one that had 2 different ones. Remember, this was a beginning and a change, and this was a total. All right, so from here, it's just a matter of solving. I like the first equation. The first equation is in standard form. The second equation needs to get manipulated. I'm going to move the X over and then the 8 over. From here, what haven't I done yet? I'll do A inverse B this time. So I need to make my A matrix, quit, and then quit again. Need to go into matrix. I need to make my A matrix. So I'm going to edit. It's a 2 by 2. 2, 3, -1, and 1. Going to make my B matrix, which is a 2 by 1. That's 156 and -8. Quit. A inverse B. And we get a solution of X equals 36, Y equals 28. Now we got to go back and read the question. How many Sundays and cones were sold all together that day? So X represents the number of Sundays, Y represents the number of cones, and if we want to know how many were together, we would add those 2 values. 36 plus 28 ends up being 64. So they sold a total of 64 Sundays and cones. All right, so a lot going on in these notes. So we first went over how to write up equations. So that's this whole front side is the way to recognize the three styles of equations. So you could have a total, you could have a beginning and a change, or you could have a related. And so I'm expecting you to recognize which one is which. Then we also tackled how to solve systems of equations on our calculator. So there's two options. You could do A inverse B, or you could do Poly-Simon. Either one, it doesn't matter to me. All right, go get them.